A second really significant effect of water's interesting properties is something that we call temperature moderation or temperature modulation, um, which basically means that water keeps its temperature fairly stable, and it's very difficult to change the temperature of water, either going up or going down, heating it up or cooling it. And in chemical terms, in scientific terms, we say that water has a high specific heat, that there's a lot of energy needed. Uh, you have to put a lot of energy into water in order to get the temperature to go up. And you've experienced this when you put a pot of water on the stove and are waiting for it to get warmer, waiting for it to boil. If you want to make spaghetti, it takes a long time, whereas other materials might raise their temperature much faster. So why does water have such a high specific heat? Well, it's because um, uh, as the water molecule, I'm sorry, as the temperature goes up, the water molecules move faster and they move past each other faster. So in order to do that, you have to break the hydrogen bonds between the water molecules for them to sort of escape each other. To break those hydrogen bonds, heat has to be absorbed. So you have to put a tremendous amount of heat into water to keep breaking all those annoying little hydrogen bonds to get the water molecules to move faster past another, which then causes the temperature to go up, which causes then the which causes it to take a long time for the temperature to go up. Sorry, I'm stumbling over my words here. Um, the opposite is true also for water molecule. So for water to cool, um, hydrogen bonds are going to form because the water molecules are going to move more slowly, and that's going to cause heat to be released, causing the temperature to drop more slowly. This is actually a good thing because temperatures in lakes and ponds won't fluctuate, won't change very dramatically with air temperature changes. So if it gets cold at night, the temperature of a lake or a pond will not drop dramatically. That's important for organisms that live in there so they don't die from shock from temperatures going up and down drastically really, really fast. So here's a few questions. One of the things that's important for living organisms that relates to this is something that's called evaporative cooling. So for example, we sweat. Let me actually put that on here. We sweat. The reason why we sweat is to cool us down. You'd probably already know this. When sweat is formed, water is at the surface of our skin, which causes the water to evaporate. And as it evaporates, water molecules leave, which means hydrogen bonds have to be broken, which absorbs heat from your skin, and that draws heat out of your body. And that's the same thing with this question, but you can come up with your own answer. When you get out of the swimming pool or you get out of a lake, you're wet, you have water molecules all over your surface, you're going to feel cold, especially if it's windy. Think about what the wind might do to the water molecules at the surface of your skin. What effect will that have, and why does that feel even colder then? Something to think about. So we say water's heat of vaporization is very high. In other words, it takes a lot of energy or a lot of heat to get water to vaporize, and once again, that's just because we have to break those hydrogen bonds. Hydrogen bonds have to be broken, and that requires a whole bunch of heat, which gets absorbed. How does this affect various regions and ecosystems? Well, large bodies of water, like a lake or a large river, maybe an ocean, have a cooling effect on the surrounding regions. And we usually say it's cooler by the lake. If we go to downtown Milwaukee, it tends to be a little bit cooler in the summer because Lake Michigan has this cooling effect on the entire region, and that's important for living organisms. So we can see on this map here, this is a map of California right by the Pacific Ocean. We can see that at the coast, the temperatures tend to be quite a bit lower because of the cooling effect of the ocean, versus as you go inland, the temperatures go up much more dramatically.